Hello, my name is Zoey, and today we'll talk about Brahmagupta's theorem, how to find an area of a quadrilateral. So, who is Brahmagupta? He's an Indian mathematician and an astronomer who lived from 598 to 668 CE, and he was the first person in the history to define the property of the number 0. And to be specific, he defined the 0 as a number that you get if you subtract the number from itself. And he also discovered the formula for solving quadratic equations. But still, he was an astronomer, so he indicated that Earth is closer to the moon than the sun. And the achievement that we'll talk about today, he produced Brahmagupta's theorem to find the area of a quadrilateral. Before getting started, there's some stuff that should be stated. First, angle BCD equals to 180 minus theta because of inscribed quadrilateral theorem, which states that opposing angles of an inscribed quadrilateral are supplementary. Second, uppercase S will stand for area of the square ABCD throughout the proof. Let's get started. First, S equals to triangle ABD plus triangle BCD as shown in the diagram. And if we use sine to find the area, it will produce the equation below when we substitute those area. And because sine 180 minus theta equals to sine theta, we can substitute those numbers. And we know that sine theta plus sine theta equals to minus cosine squared theta. So we can produce the equation below. To move on to the next step, we need to know the law of cosines, which states that c squared equals to a squared plus b squared minus 2ab cosine c. And if we apply this law of cosines to our diagram shown to the right, it will produce bd squared equals to a squared plus d squared minus 2ad cosine theta, which is for triangle ABD, and same for the BCD below. And because cosine 180 minus theta equals to minus cosine theta, we can substitute those numbers also. And if you combine those two equations above, we can get to a squared plus d squared minus 2ad cosine theta equals to b squared plus c squared plus 2bc cosine theta. And if we transpose those numbers, we can get to cosine theta times 2ad plus 2bc equals to a squared plus d squared minus b squared minus c squared. And if we divide each side by 2ad plus 2bc, we can get to the final equation shown below. So now we know the value of cosine theta. So we can substitute this number to the equation for the area of the quadrilateral. First, we need to substitute cosine theta to the equation. Then we take ad plus bc divided by 2 in the root and we calculate those numbers. Then we can see that AD plus BC squared will cancel out, and we result with the following equation shown below. Then, as you can see, color-coded parts can be simplified into even simpler form, which results in AD plus D squared minus B minus C squared times B plus C squared minus A minus D squared. And I just figured out there's a little mistake there. The square should be outside of the parentheses instead of inside. Now we know that this form corresponds to x squared minus y squared form. We can expand it to the equation below. Now let's say that lowercase s stands for semi-parameter of the quadrilateral, which can be a plus b plus c plus d divided by 2. Then if we substitute lowercase s to the equation above, we can produce even simpler form of Brahmagupta's theorem, which is square root of s minus a times s minus b times s minus c times s minus d. And this is how to prove Brahmagupta's theorem to find an area of the quadrilateral with only the parameter.